Chañar Brea gum, CBG, is obtained from the exudate of the Parkinsonia precox X Suicidium precox tree, also known as the Palo Verde. This gum is collected from trees in Chaco Forest, Argentina, from intentional superficial cuts or accidental wounds on the trunks and branches of the tree. Gum production is highest during spring and summer. Once harvested, the gum is purified by dissolving it in water, filtering it, then drying and grinding it to obtain a powder. To prepare a Chañar Brea gum film, the purified powder is dissolved in distilled water. A plasticizer, such as glycerol, is then added to improve its mechanical properties, and the solution is spread in a thin layer and dried to form a uniform film. The quality of the film depends on the gum concentration, the amount of plasticizer, and the relative humidity of the environment during drying. By using heat and pressure to bond the film layers, we can heat seal 10% Chañar Brea gum packaging in a rectangular 18 x 12 cm container. Given its hydrocolloid nature, precise control of temperature and time is required to achieve an effective bond without degrading the material. This process can be used to create biodegradable and edible packaging, taking advantage of Chañar Brea gum tar's natural properties as a protective barrier. Heat sealing was performed on 2 x 10 cm strips of Chañar Brea gum in the horizontal and vertical directions. We employed a joint determination method to explore the fundamental properties of the films. Methods included proximate analysis, Fourier transform infrared spectroscopy, differential scanning calorimetry, thermogravimetric analysis, differential thermogravimetric analysis, X-ray diffraction, and mechanical testing. We measured antioxidant capacity, water vapor permeability, water sorption, and biodegradability. By integrating the results, this study seeks to evaluate and explain the intimate relationships and complex interconnections among the molecular structure, composition, thermal behavior, mechanical properties, and barrier properties of Chañar Brea gum films. We also investigated how these fundamental properties dictate and control the film's heat sealability. The thermal stability of CBG reached up to 200 degrees Celsius, with a melting point of 152.48 degrees Celsius. Their interstrand spacing was very similar, at 4.88 nanometers for CBG and 4.66 nanometers for CBGH. The scanning electron microscope images of the heat seal showed rounded shapes on the surface, while in the cross-section it was homogeneous and almost without gaps. The WVP decreased from 1.7 to 0.37 for CBG and CBGH respectively. The Young's modulus decreased from 132 megapascals for CBG to 96.5 megapascals for CBGH. The heat sealability was 656 newtons per meter with a biodegradability of 4 days. This comprehensive approach is crucial for optimizing the sealing process and designing functional and efficient biodegradable packages. Chañar Brea gum is a promising innovation for biodegradable and edible packaging. Its heat sealability and impressive biodegradability position it as a sustainable alternative. This extensive research demonstrates its thermal, mechanical, and barrier properties, which are vital for optimizing its use. This natural advancement offers a sustainable future for the packaging industry.